The change of base formula is a way for us to be able to approximate any given log no matter what the values of the numbers are. So in words, this means that log of some base b, probably an unpretty base, of x equals log of some other base d, probably something we can work with easily, such as e or 10, of x divided by log of that other base d of b. So in numbers, that means, say, log base 2 of 300 is the same thing as the natural log of 300 divided by the natural log of 2. Now you could pick a different number rather than natural log, but we're already very good at working with natural logs, and our calculator literally has a button to work with natural logs. So let's go ahead and start working with this. So let's say on our calculator we're going to go ahead and plug in 300 natural log gives me, and you're going to want to write it out to probably about 6 or 7 decimal places just to make sure that you're being as precise as possible. 5.7037825 divided by natural log of 2 is 0.693142. So now we're going to go ahead and divide them, and I believe on your homework I say estimate to 3 decimal places, but whenever you're doing this division in between, you still want far more than 3 decimal places written out on your paper, just so that you actually get an accurate estimate. 0.7825 divided by 0.693142. So that gives me as an estimate 8.229. Since remember, you're always looking at the number right behind there to determine does it round up or down. 8 rounds up, so then that becomes a 9. And that's all you're expected to do. Because the reality is our calculator doesn't have a log base whatever I want button, but I can always change whatever base I want into the change of base formula in order to estimate it. Let's try another one together. Let's say I have log base 12 of 57. Going to be something weird because it's really asking ourselves 2 to the what power gives me 57. Just like up here, ask me 2 to the what power gives me 300. Well, it's 2 to the 8.229 approximately. So 2 to the something between 8 and 9. Here, 12 to the what power gives me 57. We don't know yet. We're going to find out. Go ahead and pause the video and try to do this on your own. Hello, welcome back. So we should be doing natural log of 57 divided by the natural log of 12. And again, when I write my in-between step, I should be including far more decimals than I really think should be necessary, just because I want to make sure I get as accurate as possible. So we're going to go ahead and do 57 natural log gives me 4.04305313 divided by 12 natural log gives me 2.484907, and now I actually do that division. So it's going to be a lot of typing on your calculator, but the idea is that no matter where you occur it, where you find it, you can always find the value of any log that you want. And I have actually seen this pop up on the ACT before too, so it's a good thing to know. So that becomes about 1.627. And I just asked for 3 decimals, so you're good there. So that's the idea. Go ahead, and if you want to take a picture, go ahead and do that. I'm not going to overkill you with examples because it's truly just plugging and chugging into a formula. That's all you're doing. If you wanted to use log base 10 instead, because there's a button for that on your calculator, it'll come out to be the same thing. You're looking at a ratio fundamentally either way. Good luck, and let me know if you have any questions. This is the last log thing that we're doing, where it's really just number manipulation. After this, we're going to go into word problems, where you'll see the application of this a little bit better. Good luck.